Hello, in this lecture we will find out the radius of the red semicircle. In the drawing we have triangle ABC. Triangle ABC is a right triangle. This angle ABC equals to 90 degrees. We also know that side AB of triangle ABC equals to 3 units, and side AB is also tangent to the red semicircle at point B, and also line segment DC equals to 1 unit, and the hypotenuse AC is tangent to the red semicircle at point E, and we want to find out the radius of this red semicircle. So first of all, I present to you a new rule, rule number 1, or two tangents theorem. So actually, rule number 1, or two tangents theorem, states that the lengths of two tangents from a common external point to a circle are equal. So I'll read rule number 1, or two tangents theorem again. According to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of two tangents theorem? The meaning of two tangents theorem is that if you have a circle, we have this blue circle, and we have an external point to this circle. This point P, is an external point of this black circle, because point P, because of the fact that point P is not located inside this circle nor on this circle, it is defined as an external point of this circle. And if from point P we will draw two tangents to this black circle, the first tangent will be this tangent. Will define the touching point between the first tangent to the black circle as point A, and we also have a second tangent from point P to this circle, and we will define the touching point between the second tangent to the black circle. With the black circle, we will define the touching point with of the second tangent with the black circle as point B. So according to rule number 1 or two tangents theorem, the lengths of two tangents, that is to say, the length of this first tangent is PA, and the length of the second tangent is PB, and according to rule number 1 or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So if you draw two tangents from the external point P to this circle, then the lengths of those two tangents are equal, that is to say PA equals to PB. So whenever you draw two tangents from an external point to a circle to that circle, the lengths of those two tangents will be equal to each other. That is to say PA will be equal to PB. Okay, so that is the meaning of two tangents theorem, and we can actually implement the two tangents theorem in our drawing, because in our drawing we have the external point, point A, this point is an external point of this red semicircle, and from point A we have two tangents to this circle. The first tangent is tangent AB, tangent AB is tangent to the red circle at point B, and the length of tangent AB is 3 units, so we have the first tangent that is AB, and the second tangent is AE, and according to rule number 1, the length of two tangents that are drawn from the external point A to the circle, the lengths are equal, that is to say AB equals to AE according to two tangents theorem. AB equals to AE. But we know that AB equals to 3 units. It is given us in the question that AB equals to 3 units. So from this equality, we derive that AE also equals to 3 units. So AE, we can write here that AE equals to 3 units in its size. So in the next step, we will define the center of this red semicircle as point O, and actually BO is the radius of this semicircle, because of the fact that it starts from the center of the semicircle, that is to say from point O, and ends at point B, that is the point on the semicircle itself. Therefore, BO is the radius of this red semicircle. We will define the radius of the semicircle as R. So BO will be equal to R. Likewise, OD is also the radius of this semicircle, because it starts from the center of the semicircle and ends at point D, that is a point on the semicircle itself. Therefore, OD is the radius of this semicircle, that is to say it equals to R. Then we will join together points O and E by a straight line. Actually, line segment OE is also the radius of this semicircle, because of the fact that it starts from the center of the semicircle and ends at point E, that is the point of the semicircle itself, on the semicircle itself. Therefore, it is the radius of this semicircle, that is to say it equals to R. And the tangent AC or side AC is tangent to this red circle at point E. Point E is the point of tangency. Of tangent AC with this red semicircle. So I will present to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tendency. So I'll read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tendency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle the center of this circle is at this point, we define the center of this circle as point O, and we have tangent to this circle actually tangent AB. This tangent is tangent to this black circle at this point. We will define this point as point M. Point M is the point of tangency of tangent AB with the black circle, point of tangency. And we have the radius from O to M. So this radius, the radius OM, is drawn to the point of tendency. Okay, so according to rule number 2, a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tendency. So this radius, the radius OM, is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency. Therefore, according to rule number 2, the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees. It is a right angle, and this angle also equals to 90 degrees. It is also a right angle. So, according to rule number 2, whenever you have a radius that is drawn to the point of tendency, in this case it is point M, then the tangent AB will be perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so a tangent to a circle, AB, tangent AB, is perpendicular to the radius drawn to its points of tendency. This tangent AB is perpendicular to this radius because this radius is drawn to the point of tendency. Therefore, the tangent AB is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And we can actually implement rule number 2 in our drawing, because in our drawing we have this radius that is drawn to the point of tendency, that is to say it is drawn to point E, that is a point of tangency of tangent AC with this red semicircle. Therefore, the tangent AC is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, because of the fact that this radius is drawn to the point of tendency, that is to say it is drawn to point E, that is the point of tendency, then the tangent AC is perpendicular to this radius, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees also. So because of the fact that angle OEC is a right angle, it equals to 90 degrees, then triangle OEC is a right triangle because it has one angle that equals to 90 degrees. So this triangle OEC, is a right triangle So we will focus on the right green triangle, triangle OEC. So in triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is side OC of the green triangle because of the fact that it's located in front of the right angle. So the hypotenuse is OC, so the square of the hypotenuse is OC square. And it equals to the sum of the squares of the perpendiculars, that is to say it equals to OE square plus EC square. I will repeat again. In the right triangle, right green triangle, triangle OEC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say OC square equals to OE square plus EC square. Okay, but what is the value of OC? The value of side OC of the green triangle, it is actually R plus 1. So if OC equals to R plus 1, then OC square will be equal to R plus 1 square. So OC equals to R plus 1 square. And what is the value of OE? The value of OE, as you can see from the drawing, it equals to R, the radius of the semicircle. So OE square will be equal to R square plus EC square. We will define the size of EC as X, that is to say EC equals to X unit in its size. So EC is equals to X, so EC square will be equals to X square. So in total we found out that R plus 1 square equals to OE, that is OE square, it is R square, plus EC square, that is X square. Here we open the brackets in this equation number 1 and we will get that R plus 1 square equals to R square plus 1 plus 2R, according to the algebraic identity that A plus B square equals to A square plus B square plus 2 times AB, and it equals to R square plus X square. Here we have R square in both sides of equation number 1, so we will subtract R square from equation number 1. So r squared will get cancelled. And what is left after we cancelled r squared? What is left? It is actually 1 plus 2r equals to x squared. So we found out that according to equation number 1, 1 plus 2r equals to x squared. Okay, so in the next step, we will focus on two triangles, the right big triangle, triangle ABC, and the small green right triangle, triangle OEC. Okay? Triangle ABC and triangle OEC. And we will actually prove that those two triangles, the triangle ABC is similar to triangle OEC, the green triangle. Okay, so we will focus on the right big triangle, triangle ABC, and on the green right triangle, triangle OEC. Okay. So first of all, we know that those two angles equal to each other, they are both right angles. Okay, so actually angle ABC of triangle ABC, this angle equals to angle OEC of the green triangle, and both those two angles are right angles, they are equal to 90 degrees. So actually angle ABC equals to angle OEC equals to 90 degrees. This angle, it is actually a right angle. It belongs to both triangles. It belongs to the big triangle, triangle ABC, and it also belongs to the green triangle. So we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. So angle C equals to angle C is a common angle that belongs to both triangles. And those two angles are also equal to each other according to third angle theorem. So this angle, angle BAC of triangle ABC, equals to angle EOC, this angle of triangle EOC, and they are equal to each other according to third angle theorem. I will repeat again. Angle BAC equals to angle EOC, and they are equal to each other according to third angle theorem. So what is third angle theorem? Or we can also call it rule number 3. So rule number 3 or third angle theorem So, according to rule number 3 of third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So I read rule number 3 of third angle theorem again. According to third angle theorem, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of rule number 3 of third angle theorem? The meaning of third angle theorem is that if you have two triangles, triangle ABC, we have triangle ABC, so this is triangle ABC, and we also have a second triangle, triangle DEF. This is triangle DEF. So in those two triangles we have two pairs of angles that congruent. The first pair of angles that congruent is this angle is alpha and this angle also equals to alpha, so those two angles congruent. And the second pair of angles that congruent is this angle is beta and this angle is also beta, so they are congruent to each other. So we have two pairs of angles that congruent. And this angle is gamma and this angle is theta. So if we have, like in this drawing, two angles that congruent, two pairs of angles that congruent to each other, like in this drawing, then the third pair of angles must be also congruent. That is to say, angle gamma must congruent to angle theta, or angle gamma equals to angle theta. I'll repeat again, if we have in two triangles two angles that congruent to each other, like here, then the third pair of angles must also congruent, that is to say, angle gamma must equal to angle theta. So we will prove that the third angle theorem is true. We will prove the theorem according to the rule that the sum of the angles in any triangle equals to 180 degrees, and especially the sum of the angles in triangle ABC equals to 180 degrees. that is to say alpha plus beta plus gamma equals to 180 degrees. I will repeat again. In the right triangle, triangle ABC, the sum of its angles equals to 180 degrees. That is to say alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles also equals to 180 degrees. So in triangle DEF, the sum of the angles equals to 180 degrees. That is to say alpha plus beta plus theta equals to 180 degrees. I will repeat again. In triangle DEF, the sum of its angles also equals to 180 degrees. That is to say alpha plus beta plus theta equals to 180 degrees. Here we'll subtract equation number 1 from equation number 2, and we'll get that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we found out that gamma minus theta equals to 0. Okay, here we will add theta to equation number 3, and we will get that angle gamma equals to angle theta, and that is exactly what we wanted to prove. We actually proved that if we have two triangles with two pairs of angles that congruent, then the third pair of angles must also congruent, that is to say angle gamma equals to angle theta. We proved that angle gamma equals to angle theta. Therefore, we actually proved that the third angle theorem is true. Okay, so we will return to our original drawing. Here, we actually proved that all three angles of triangle ABC congruent to all three angles of the green right triangle, triangle OEC. Okay, therefore we actually proved that the big right triangle, triangle ABC is similar to the green triangle, triangle OEC. We proved that the big right triangle, triangle ABC is similar to triangle DEF according to angle similarity rule. I'll repeat again. We proved that triangle ABC is similar to triangle DEF according to angle similarity rule. So, what is angle similarity rule? When you prove that all three angles of one triangle congruent to all three angles of the other triangle, you actually proved that those two triangles similar to each other according to angle similarity rule. Okay, so from the fact that triangle ABC is similar to a green triangle, triangle DEF, we will conclude that AB over AC in triangle ABC equals to OE over OC in triangle OEC, the green triangle. I'll repeat again. we will conclude that AB over AC equals to, in triangle ABC equals to OE over OC in triangle OEC. Okay, but what is the value of AB? The value of AB according to what is given us the question, it equals to 3 units. So AB equals to 3. And what is the value of AC? As you can see from the drawing, the value of AC is 3 plus X. So actually here AB equals to 3 units and AC equals to 3 plus X units, and all equals to OE. OE is the radius of the red semicircle, so it equals to R. And what is the value of OC? From this drawing you can see that the value of OC is R plus 1. So we actually found out OE equals to R, OC equals to R plus 1. So in total we found out that 3 over 3 plus X equals to R over R plus 1. Here we will cross multiply equation number 2, and we will get that three times R plus 1 equals to R times 3 plus X. Okay, we cross multiplied this equation number 3 and we got this expression that 3 times R plus 1 equals to R times 3 plus X. Here we will open the brackets in both sides of equation number 2 and we will get that R plus 3 equals to 3R plus R times X. Okay. So we found out that R plus 3 equals to 3R plus Rx. So here we have 3R on both sides of the equation, so we'll subtract 3R from equation number 2, this equation. So 3R will get cancelled, and what is left after we cancel 3R? What is left? It is actually three equals to R times X. Here we divide this equation by X. Why it is allowable to divide the equation by X? Maybe X is 0, but as you can see from the drawing, X equals to EC. EC is one side of the green triangle, and the side of a triangle must be a positive number. It can never be 0. Therefore, it is allowable to divide this equation number 2 by X, because X can never be 0. Okay, it's the side of the triangle, X can never be 0. So we will divide equation number 2 by X, and we will get that the radius of the semicircle equals to 3 over X. We found out that the radius of the semicircle equals to 3 over X, but we have already found out, according to equation number 1, that 1 plus 2R equals to X squared. So here we will substitute 2r in this equation number 1 by 3 plus x, because r equals to 3 plus x according to equation number 2. Okay, so we'll do it now. We'll get that 1 plus 2 times r, and r is 3 plus x according to equation number 2. So it is 3 plus x equals to x squared. So here plus 2 times 3 over x equals to x squared. 2 times 3 is 6, so we write it down. So according to equation number 1, 1 plus 2 times 3 is 6, so it is 6 over x equals to x squared. So here we will multiply this equation number 1 by x, and we will get that x times 1 is x, 6 over x times x is 6, 6x squared times x is x cubed. So here we'll subtract x from this equation number 1, and we'll get that x cubed minus x equals to 6. Here we will subtract 6 from this equation number 1, and we will get that x cubed minus x minus 6 equals to 0. So here we will add 0 to this equation. Actually 0 is minus 2x squared plus 2x squared equals to 0. So this equals to 0, so we can add 0 to any equation. So we will add minus 2x plus 2x, that is 0 actually. So we change nothing because it is allowable to add to any equation 0. So we will add to equation number 1 minus 2x plus 2x, that equals to 0. And we will get that x cubed minus 2x squared plus 2x squared, that is 0. Minus x minus 6 equals to 0. So here we will substitute this minus x by minus 4x plus 3x equals to minus x. Therefore we will substitute, we can substitute minus x in this equation number 1 by minus 4x plus 3x, that equals to minus x. So we'll do it now, and we will get that according to equation number 1, x cubed minus 2x squared plus 2x squared, and instead of x minus x we will write down minus 4x plus 3x minus 6 equals to 0. So this is the equality that we got after we substituted minus x by minus 4x plus 3x. So here we will divide this equation number 3 to 3 parts, and then we will take a common factor from each part. Okay, so part number 1 will be this part. Okay, this will be part number 2, and this will be part number 3. Okay, so we will copy part number 1 that is actually part number 1 is x cubed minus 2x squared, and we will take a common factor from this expression. We will take x squared as a common factor of this expression. So if we took x squared as a common factor of x cubed, what is left inside the brackets? Inside the brackets, what is left, it is actually x. Again, if we took a common factor of x squared from x cubed, what is left inside the bracket, it is x. And if we take a common factor of x squared from minus 2x squared, what is left inside the brackets? Inside the brackets, what is left is minus 2. So in total we got that x cubed minus 2x squared equals to x squared times x minus 2. Okay, we will do the same process on expression number 2. Expression number 2 is 2x squared minus 4x, and the common factor that we will take from this expression is 2x. So here, what is left from 2x squared after we took a common factor of 2x? What is left? It is actually x. And what is left from minus 4x after we took a common factor of 2x? What is left? It is actually minus 2. So in total we got that 2x squared minus 4x equals to 2x times x minus 2. We will do the same process on the further expression. The further expression is 3x minus 6, and the common factor that we will take from 3x minus 6 is 3. So what is left from 3x after we took 3 as a common factor? What is left? It is actually x. And what is left from minus 6 after we took a common factor of 3 from it? What is left? It is actually minus 2. So in total we got that 3x minus 6 equals to 3 times x minus 2. So here we found out that x cubed minus 2x squared equals to x squared times x minus 2. 2x squared minus 4x equals to 2x times x minus 2, and 3x minus 6 equals to 3 times x minus 2. So we'll substitute those three expressions by their identities, and all the sum of those three expressions, as you can see from equation number 1, equals to 0. So we'll substitute x cubed minus 2x squared by x squared times x minus 2. And we will substitute 2x squared minus 4x by 2x times x minus 2. And we will substitute 3x minus 6 by 3 times x minus 2. And the sum of those three expressions equals to 0, so it equals to 0. So we found out that this is actually equation number 1 after we substituted those three expressions by their identities. Okay, here we will take a common factor of x minus 2 out of this equation number 1, and we will get that x minus 2 is a common factor. So what is left from x squared times x minus 2 after we took x minus 2 as a common factor? What is left? It is actually x squared. And what is left from 2x times x minus 2 after we took a common factor of x minus 2? What is left? It is actually 2x. And what is left from 3 times x minus 2 after we took x minus 2 as a common factor? What is left? It is actually 3. So in total we got this equation number 1. Equation number 1 states that x minus 2 times x squared plus 2x plus 3, actually it equals to 0. I forgot the 0 here. It equals to 0, as you can see. 0, so it equals to 0. So actually here this equation number 1 has two possible solutions. Either x minus 2 equals to 0, and if x minus 2 equals to 0, then everything that is multiplied by 0 is 0, so 0 will be equal to 0. And the other option is that x squared plus 2x plus 3 equals to 0, and if it equals to 0, then whatever we will multiply by 0, it is 0, so we'll get the 0 equals to 0. So I'll write down those two solutions that are possible for this equation number 1. The first solution that is possible for this equation number 1 is that x minus 2 equals to 0. And the second solution that is possible for this equation number 1 is that the quadratic equation x squared plus 2x plus 3 equals to 0. And we will focus on this solution, the second solution. The second solution is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c in this general quadratic equation are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So we will use this formula for x in order to find out the value of x in our specific quadratic equation. And in this quadratic equation, the coefficients are as follows: a equals to 1, the coefficient b equals to 2, and the coefficient c equals to 3. So we will put the data inside this equation in order to find, inside this formula, in order to find out the value of x in our specific quadratic equation, and we will find out that the value of x in our specific quadratic equation is equal to, according to this formula, x equals to minus b, b equals to 2, so minus b is minus 2, plus minus square root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, minus 4 times 1, times c is 3, so it is minus 4 times 1 times 3 over 2 times a is 1, so 2 times 1 is 2. So we actually found out that x equals to minus 2 plus minus square root of here the square root of 4 minus 4 times 1 times 3 is minus 4 times 1 times 3 is minus 12 over 2. Okay, so we actually found out that the value of x is equal to minus 2 plus minus square root of 4 minus 12 is minus 8 over 2. Okay, but here minus 8 is a negative number, and because of the fact that a negative number doesn't have a root, it means that this quadratic equation x squared plus 2x plus 3 doesn't have a solution because of the fact that we don't have a root for a negative number. Therefore, the quadratic equation x squared plus 2x plus 3 equals to 0 doesn't have a solution, so this possibility is cancelled. It is not correct, and we left only with the possibility that x minus 2 equals to 0. So if x minus 2 equals to 0, then x equals to 2, and we have already found out, according to equation number 2, that the radius of the semicircle equals to 3 over x. And we have already found out that x equals to 2, so we can substitute x by 2 because x equals to 2, and we will find out that the radius of the semicircle equals to 3 over x, and x is 2, so the radius of the semicircle equals to 3 over 2 units, or we can represent it as 1.5 units. Okay, we have the solution for the radius of the semicircle, the red semicircle. It equals to either 3 over 2 units or it equals to 1.5 units. So I will repeat on the question. The solution to the question is that the radius of this semicircle R equals to either 3 over 2 units, or it also can equal to 1.5. We can represent it that R equals to either 3 over 2 units or it equals to 1.5 units. Okay? So now I will summarize the lecture. Actually, we wanted to find out the radius of this semicircle we know that in triangle ABC is a right triangle. That is to say, angle ABC equals to 90 degrees, side AB equals to 3 units, line segment DC equals to 1 unit, and we want to find out the radius of this right semicircle. So first of all, I presented to you rule number 1. According to rule number 1 or two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this circle, this black circle, and we have external point of this black circle, P is the external point of this black circle, and from point P, the external point P, we draw two tangents to this circle, tangent PA and tangent PB, then the lengths of those two tangents are equal to each other. The length of this first tangent is PA, the length of the second tangent is PB, and according to rule number 1, that the lengths of two tangents from a common external point, that is to say from point P to a circle, are equal, it means that PA equals to PB, because whenever you draw two tangents from an external point to a circle to that circle, then the length of those two tangents will be equal to each other. That is to say, PA equals to PB. Okay, that is rule number 1 or two tangents theorem, and we actually implemented rule number 1 or two tangents theorem in our drawing. In our drawing, we have the external point A. Point A is an external point in relation to this semicircle, and from point A we have two tangents to this red semicircle, the first tangent is tangent AB, the length of tangent AB is 3 units, and we have a second tangent from point A to this semicircle. The second tangent is tangent AE. So, and according to rule number 1, the length of two tangents from an external, a common external point to a circle are equal. So, according to rule number 1 of two tangents theorem, AB equals to AE. Okay? AB equals to AE, but we know that AB equals to 3 units. This is given us in the question. So, from this equality, we will derive that AE also equals to 3 units. So, AE, line segment AE equals to 3 units. Okay? Then I presented to you also rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is actually that if we have this black circle and we have tangent AB is tangent to this black circle at point M. Point M is the point of tangency of tangent AB with this black circle. According to rule number 2, a tangent to a circle, that is to say AB, is perpendicular to the radius drawn to its points of tangency. So this radius OM, it is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency. Therefore, the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Whenever you have a radius, like in this drawing, that is drawn to the point of tangency, then the tangent, in this case, tangent AB will be perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, that is rule number 2. And we actually implemented rule number 2 in our drawing. In our drawing, we have tangent AC, that is tangent to this red semicircle at point E. Point E is the point of tangency of tangent AC with this red semicircle. And we have the radius OE. This radius OE, it is drawn to the point of tangency, that is to say it is drawn to point E, that is the point of tangency. Therefore, according to rule number 2, this tangent AC is perpendicular to this radius OE. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. And because of the fact that angle OEC, this angle equals to 90 degrees, then the green triangle is a right triangle. So we focused on the right triangle OEC. According to the Pythagoras theorem, in the right triangle OEC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is OC because it is located in front of the angle that is a right angle. So the square of the hypotenuse is OC square equals to the sum of the squares of the perpendiculars. That is to say, it equals to OE square plus EC square. Again, OC square equals to OE square plus EC square. But what is the value of OC? You can see from the drawing that the value of OC is R plus 1. Okay, so OC equals to R plus 1, so OC square will be equal to R plus 1 square. And what is the value of OE? OE, you can see from the drawing that OE equals to R, so OE square will be equal to R square. And what is the value of EC? The value of EC is X, as you can see from the drawing. So if EC equals to X, then EC square will be equal to X square. So in total we got that R square equals to R plus 1 square equals to R square plus X square. We open the brackets in this side of equation number 1, and we got that R plus 1 square equals to R square plus 1 plus 2R, and it equals to R square plus X square. Here we subtracted R square from equation number 1 because we have R square on both sides of the equation. And what is left after we subtracted R square from equation number 1? What is left? It is actually 1 plus 2R equals to X square. So according to equation number 1, 1 plus 2R equals to X square. Okay, then we focused on the right triangle, triangle ABC, and on the green right triangle, triangle OEC, and we proved that those two triangles are similar to each other. First of all, we know that those two angles are equal to each other, they are both right angles. So actually, angle ABC equals to angle OEC equals to 90 degrees. And we also know that this angle, angle C, is a common angle. It belongs both to triangle ABC, and the angle C, this angle also belongs to the green triangle. So we can write down that angle C equals to angle C. It's a common angle that belongs to both triangles. Then we actually proved that those two angles are equal to each other according to third angle theorem. That is to say, angle BSC equals to angle EOC according to the third angle theorem. So what is third angle theorem? Third angle theorem states, or rule number 3, if two angles of one triangle congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of the third angle theorem? The meaning of the third angle theorem is that if you have those two triangles, triangle ABC and triangle DEF, and those two triangles have two pairs of angles that congruent to each other. This is the first pair of angles that congruent, and this is the second pair of angles that congruent. So if this is the situation, then the third pair of angles must also congruent, that is to say, angle gamma must equal to angle theta. So we actually proved that the third angle theorem is true by using the rule that the sum of the angles in any triangle equals to 180 degrees. The sum of the angles in triangle ABC equals to 180 degrees, that is to say, alpha plus beta plus gamma equals to 180 degrees. In triangle ABC, the sum of its angles equals to 180 degrees, that is to say, alpha plus beta plus gamma equals to 180 degrees. Likewise, in triangle DEF, the sum of its angles equals to 180 degrees, that is to say, alpha plus beta plus theta equals to 180 degrees. In triangle DEF, alpha plus beta plus theta equals to 180 degrees. Here we subtracted equation number 1 from equation number 2 and we got that alpha minus alpha is 0, beta minus beta is 0, and gamma minus theta equals to 180 degrees minus 180 degrees is 0. So we found out that gamma minus theta equals to 0. We added theta to equation number 3 and we found out that angle gamma equals to angle theta. So we actually proved that if we have two triangles with two pairs of angles that are equal to each other, then the third pair of angles must be also equal to each other, that is to say, angle gamma equals to angle theta. And we indeed proved that angle gamma equals to angle theta, therefore we proved that the third angle theorem is true. And if we return to our drawing, in total we proved that all three angles of the right big triangle, triangle ABC, congruent to all three angles of the small green triangle, green right triangle, triangle OEC. Therefore, we actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. So we proved that triangle ABC is similar to triangle OEC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all three angles of one triangle congruent to all three angles of another triangle, then you proved that those two triangles similar to each other according to angle similarity rule. And from the fact that triangle ABC is similar to the green triangle, triangle DEF, we will conclude triangle OEF, we will conclude that AB over AC equals to OE over OC. Again, we will conclude that AB over AC in triangle ABC equals to OE over OC in the green triangle, triangle OEC. Again, AB over AC equals to OE over OC. But what is the value of AB? AB equals to 3 units according to what is given us in the question. And side AC, the hypotenuse equals to 3 plus x, as you can see from the drawing. So AB equals to 3 units, AC equals to 3 plus x. OE, as you can see from the drawing, OE equals to R. And OC, as you can see from the drawing, equals to R plus 1. So OE equals to R, OC equals to R plus 1. So in total we got that 3 over 3 plus x equals to R plus 1. Here we multiplied the equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus x. We opened the brackets in equation number 2, and we found out that according to equation number 2, 3R plus 3 equals to 3R plus Rx. Here we have 3R on both sides of equation number 2, so we can subtract 3R from equation number 2, and we got that 3 equals to R times x. Here we divided this equation by x. It is allowable to divide by x because x is the one side of the green triangle OEC, so x must be a positive number as a side of a triangle. It can never be 0, so it is allowable to divide equation number 2 by x. So we divided equation number 2 by x, and we got that the radius of the semicircle that we are looking for equals to 3 over x. That is according to equation number 2, but we have already found out that according to equation number 1, 1 plus 2r equals to x squared. So here we can substitute r by 3 over x, because r equals to 3 over x according to equation number 2. So we substituted r by 3 over x, and we got that 1 plus 2 times 3 over x equals to x squared. 2 times 3 is 6. So we got that 1 plus 6 over x equals to x squared. Here we multiplied equation number 1 by x, and we got that x times 1 is x, 6 over x times x is 6, and x squared times x is x cubed. So in total we got that x plus 6 equals to x cubed. Here we subtracted x from equation number 1, this equation, and we got that x cubed minus x equals to 6. We subtracted 6 from this equation, and we got that x cubed minus x minus 6 equals to 0. So here we added 0 to this equation number 1. 0, it is actually minus 2x squared plus 2x squared is 0. So we added this expression that equals to 0 to equation number 1, and we got that x squared minus 2x squared plus 2x squared, that is 0, minus x minus 6 equals to 0. And in this step we subtracted minus x by minus 4x plus 3x, because minus 4x plus 3x equals to minus x. So we substituted minus x by minus 4x plus 3x, and we got this equality that x cubed minus 2x plus 2x squared minus 4x plus 3x minus 6 equals to 0. We divided equation number 1 to 3 parts, and we took a common factor from each part. The common factor that we took from the first expression is actually x squared, and inside the brackets what is left is x minus 2. The common factor that we took from 2x squared minus 4x is 2x, and what is left inside the brackets is x minus 2. And the common factor that we took from the third equation, from the third expression, 3x minus 6, from this expression is 3, and what is left inside the brackets is x minus 2. And we substituted those three expressions by their identities, and we got this expression Here we took a common factor of x minus 2 out of equation number 1, and when we took the common factor x minus 2 from this expression, what is left inside the brackets is x squared, and what is left from this expression after we took x minus 2 as a common factor is 2x, and what is left from this expression after we took x minus 2 as a common factor is 3. So in total we got equation number 1 that states that x minus 2 times x squared plus 2x plus 3 equals to 0. So here we have two solutions that are possible. The first solution is that either so this is the equation number 1, and we have two solutions that are possible. Either x minus 2 equals to 0, or the second possibility is that the quadratic equation x squared plus 2x plus 3 equals to 0. We focused on the second solution, and the second solution is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. A, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So in our specific quadratic equation, the coefficients are as follows: a equals to 1, b equals to 2, and c equals to 3. So we put the data inside this equation in order to find out the value of x in our specific quadratic equation, and we found out that x equals to minus b, b equals to 2, so minus b is minus 2, and plus minus the square root of b squared, b equals to 2, so b squared is 2 squared, 2 squared is 4. Minus 4 times a times c, so it is minus 4 times a is 1, so it is minus 4 times 1, and c is 3, so it is minus 4 times a, minus 4 times 1 times 3, okay, over 2. Here we found out that x equals to minus 2 plus minus 4 times 1 times 3 is minus 12, so in total we got that x equals to minus 2 plus minus the square root of 4 minus 12 over 2. Here 4 minus 12 is minus 8, but because of the fact that minus 8 is a negative number and the negative number doesn't have a root, then we can conclude that this quadratic equation doesn't have a solution, because we are stuck here. A negative number doesn't have a root. So therefore, this quadratic equation doesn't have a solution. So this possibility is cancelled, and we left only with the possibility that x minus 2 equals to 0. And if x minus 2 equals to 0, then x equals to 2. And we have equation number 2 that states that r equals to 3 over x. If r equals to 3 over x, and we found out that already that x equals to 2, so we can substitute x in equation number 2 by 2, because x equals to 2. So we substituted x by 2 in equation number 2, and we got that the radius of the semicircle equals to either 3 over 2 units, or it equals to 1.5 units. I will repeat again. The radius of this semicircle equals to either 3 over 2 units, or it equals to 1.5 units. Okay? Thank you very much.